All right, so looking at the warm-up, we need to find the 5th, the 12th, the 100th, and the nth terms. If we're looking for the 5th term in our sequence, we're going to use this formula, right? So what numbers are we going to plug into this formula? So we're looking for a to the 5th, the 5th term. That equals 2. Where'd that 2 come from?
It's our first one.
It's our first term in our sequence. Then we're multiplying by our R value. What's our R value in this case?
Common ratio times 3.
It's our common ratio, so we're multiplying by 3. So in this case, it's 3. And then what?
You take the number you're trying to find minus 1.
So in this case, 5 minus 1.
Oh, I did it actually right.
So then you're going to simplify that.
Thank you. So it'll be 6 to the 4th column.
So you end up with that this equals 2 times 3 to the 4th.
Then 6 to the 4th.
No. So that's an order of operations error.
Oh, 3 to the 4th and then times it.
So for these, remember you have to take this 3 to the 4th and then you multiply it by 2. You're not taking 6 to the 4th. That goes back to order of operations. So you should get 162. So then we want to find the 12th term. How do we find the 12th term now? So this time again we have a to the 12th, or a sub 12. And our a1 value is still 2. And our r value is still 3. What happens to our n minus 1 value?
It's 12 minus 1.
Now it's 12 minus 1. So when we simplify that, we end up with 2 times 3 to the 11th. So again, we're taking 3 to the 11th and then multiplying by 2. So you should get 354,294. So remember that for these geometric ones, our terms went up significantly. They got larger much faster than our arithmetic ones did. And then we needed to find our 100th term. What am I plugging in for my 100th term? So I have a sub 100 now. And I still have the same a1 value, the same r value. And then what's that n minus 1 this time?
100 minus 1?
It's 100 minus 1. So this time we have 2 times 3 to the 99th. So again, you're going to take 3 to the 99th, multiply by 2. When you plug this into your calculator, you're going to get an odd looking number. It's going to look like
It's like 3 trillion trillions.
3.44, and then it probably says E47.
No, it just says a lot of numbers.
Mine says a lot of numbers.
Is there a decimal though?
No.
It just has a bunch of numbers?
Bunch of numbers.
I got
3, 4, 3, 5, 8, 5, 0, 1, 3, 8, 1.
Oh, it just continues on and on and on?
continues
It's
on.
like-
Okay, so on the Inspire, it continues on and on and on. If we were using one of the other calculators, it's going to put it in this type of notation. What this notation stands for is it's in like a scientific type notation, if you've taken chemistry and that kind of stuff. So that we have this 3.44 times 10 to the 47th. What that means is you're going to multiply this 3.44 by 10 to the 47th. So that decimal place is going to move 47 places to the right. So that's just how large this number actually is. I won't actually ask you to find the 100th term for a geometric series because it is, or sequence because it is so big. That's just to show you how big these numbers can get. So then finally we needed to find the nth term. So for this one, the nth term. So before we were finding the 5th, we were finding the 12th, we were finding the 100th. We were finding specific terms. Now we're just using an n. So we're writing our formula out generally, but we want it to pertain to this sequence. So we're not going to just rewrite this formula out. We want to plug in the numbers that we know specifically for this sequence. So how are we going to write this out? So we're going to have an, and that equals 2. So we do still know our first value.
Times 3.
And then we're going to multiply by our common ratio that we know.
N minus 1.
And then we have just the 3 to the n minus 1. So that's writing this out in a general form to find the nth term. So this means that we can use this formula to find any term in this sequence. So that's going to tie into what we're talking about today. So we covered arithmetic sequences Monday and Tuesday, and then we finished it up yesterday. So today we're talking about geometric series. So when we talked about a series, what was the difference between a series and a sequence? Or more specifically, what was a sequence? What did we define a sequence as? So a sequence is just a list of numbers. But they have to be in order, remember. That was the important part. So a sequence was a list of numbers. What was a series then? So a series was the sum of the terms of a sequence. So where a sequence would have been, you know, that 2, 4, 8, so on, the series would be 2 plus 4 plus 8 plus ... So one is just a list, the other one is a sum. So today we're going to start looking at geometric series. So on your paper you have an example. We have 2 plus 4 plus 8 plus 16 plus 32 plus 64.
Sure. Thanks.
So when we look at this, what do we notice about the terms? So if we looked at this not as a sum, or not as a series, but if we rewrote it as a sequence. If we rewrote this as 2, 4, 8, 16, 32, 64. What do we notice about our terms? Do we have a pattern?
Yes.
What's our pattern? So we're multiplying by 2 each time. So what does that tell us then about this series? What does that mean? If our pattern is multiplying by 2, that tells us that it's geometric. That multiplication, that multiplying by some ratio, tells us that this is a geometric series. So like with an arithmetic series, a geometric series is the sum of a geometric sequence. So a geometric series, sum of a geometric sequence. So now, for this geometric sequence, or for this geometric series, I want you guys to find the sum. And tell me, is this, before you find the sum, is this series infinite or finite? It's finite. Why?
Because it stops.
Because it stops. So that was the difference. Infinite continued forever. Finite, you have a last term.
So when it's dot 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 after it.
So when it's dot dot dot, that means that it's infinite.
So it's just like.
Yep. So I want you guys to find the sum real quick of this. It shouldn't take very long. We're just adding 6 numbers. So what do you end up getting? 126. So now, like our example that we did with the arithmetic mean, this one was small enough that we could just add them real quick. What if you had 20 terms, 50 terms, 100 terms? Are we going to want to add all of those?
No.
No, so we're going to have a shortcut to find this sum just like we did with the arithmetic. Our geometric one is going to look a little different though. Our geometric one is going to look like a1 times 1 minus r to the n divided by 1 minus r. So we need to figure out what each of these things stands for, just like we did with the arithmetic. Yeah, go ahead, Michaela.
So is this one for like a short one like that or for a long one?
So you could use this for a short one like this, or a long one. You can use it for either or. It works for all of them. As long as they're finite. This is for a finite geometric series. That's the important part. So like with this one where it ends, as long as you have that last value, you can use this formula.
Wait, I thought that was for, you said it was for either a long one or a short one.
So if you had, 50 terms, you know how we wrote that out, that you would have, so that if I used this one, and then you would have plus, like 3,000 or something. I don't know what it would be.
So it
So-
doesn't work for an infinite one?
No, so if you just had that dot 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 one, this does not work for that. And can somebody explain why this wouldn't work for that infinite one? What's the key part in this that we need to know in order to use this?
The last.
Huh?
The last number.
So what is the last number? What do we need that last number for?
You know how many terms are?
So to know how many terms there are, right? So that's this n value, isn't it?
Yeah.
So this is our number of last term. So if we have 50 terms, we know that that n would be a 50. That's what that's saying. So if we don't have a last term, which you wouldn't in a finite because it continues forever, you wouldn't be able to use this because you wouldn't have that n value. So then what are our other values that we have in this formula? What's this a1 value? It's still our first term, just like it always has been. And then what's our r value in both cases?
Common ratio.
This is our common ratio. So we're going to have to know how to find each of those values in order to use this formula. So we're going to actually look at example 1 and see if we can use this formula. So example 1 wants us to find the sum of the finite geometric series that's listed here, which is 3 plus 6 plus 12 plus 24 plus dot 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 plus 3,072. So that's our series. And we need to find the sum of this series. So we're going to use this formula. So in order to use that formula, we need that A1 value, we need that R value, and we need the N value. So those are those three values that we're going to have to find. So for this series, do we know any of these values? Which ones do we know?
A1.
So we know A1. What is A1?
3.
3. It's our first term. How about our R value?
Times 2.
It's 2. We're multiplying by 2. How about our N value?
3072.
Our N value? Didn't we say that our N value, it's the number of the last term? It's not actually our last term. We know that 3072 is our last term. But do we know the number of this term? Do we know if this is like the 50th term?
No.
So we have to figure that out. We have to solve for our N. So does anybody have an idea how we could solve for that N value to figure out what term this is?
No.
So we did it with our arithmetic ones. How did we find which term, or how did we find our N value with our arithmetic? So we solved for N using the explicit formula for arithmetic sequences. So how are we going to find the N value for a geometric? So we're going to use the explicit formula for geometric sequences this time. So, I'll write over here. So what was our explicit formula again for geometric sequences?
A1 times R to the N minus 1.
Ladies. So our explicit formula for a geometric sequence was AN equals A1 times R to the N minus 1. And you guys told me that we're solving for N. So we need to solve for this N value. That's going to tell us what our N value is over here. So what numbers am I going to plug into this explicit formula in order to solve for that N? So, okay. So this AN, what does that become? If I'm looking for an N value for my last term, I'm going to plug in my last term, right? So that AN is going to become 3072. What was my A1 value?
3.
3. And then what was my R value?
2.
2. And then I'm solving for that N, so I still have N minus 1.
So would you just times the 3 and 2 and divide it?
So, okay, so again, that goes back to an order of operations problem. You have to take 2 to this exponent before you multiply by the 3. So we have 3 multiplied by that, or multiplying by that 2 to the N minus 1. So how can we simplify this?
2 and minus.
Do what with the 3?
Subtract the 3.
Well, we're multiplying,
Divide
so
the
we,
three.
so we're going to divide by the 3. So you're going to get 1024 equals 2 to the N minus 1.
Would it be 2 to N minus 2 and
Nope. Nope, that's always N minus 1. That's just using the formula.
Divide 2.
So now we have 1024 equals 2 to some power. So in this case, we don't know what that power is. So we can't square root or cube root.
Divide.
Or those kind of things.
Divide 2.
What you do like?
wouldn't you plus a 1 and then divide?
So in this case, when we're looking at an exponent, unfortunately, our options are kind of limited. We can either do a guess and check kind of method because we know that this 1024 is 2 to some power. you have to take 2 to some power to get this 1024. So you can do a guess and check type method. Or this goes back to logs. And I know how much you guys love the logs, so I will show you both ways. The guess and check you kind of have to do on your calculator.
It's 10.
So you got 10, just plugging it in until you find 1024. So you find 2 to the 10th equals 1024.
You can do that.
So if we're looking at this, if you know that 2 to the 10th equals 1024, what does that mean for this n minus 1?
29.
So n minus 1 equals that 10. So little side problem, 10 equals our n minus 1. So then if you're solving for n, you would add 1 and you would get 11. So that would be like the guess and check kind of method. Make sure that you actually do solve for n though. Now, if we were doing the logs, we have to rewrite this using logs. So this rewrites as log base 2. Remember that your larger number here becomes your small number. And that's log base 2 of 1024. And then that equals your exponent. Remember that a log equals an exponent. Logs have been a while, so this is kind of the refresher of logs. So now you would plug this log base 2 of 1024 into your calculator. And you should get that same 10. And that still equals our n minus 1. So again, you get that 11 equals your n. So you need to be able to find that n value, whether you use the logs or you use the guess and check. I kind of hope that you know how to use the logs, but I know logs have been a while, so. So we just solved for our n value then. So now we know that our n value over here is 11. So now do we have all the information that we need in order to use our formula?
Yes.
So now we're just going to plug these values into our formula. So we have 3 times 1 minus, our r value was 2, to the n is the 11th, and then we're dividing. And then we're dividing by that 1 minus 2. So in the Inspire, it's really nice. You can actually plug this in exactly as it appears right here. And when you plug that in, what are you guys getting? So you get 6,141. That's just a matter of plugging it in. Is anybody not getting 6,141? Everybody's good? All right. I want you guys to try example 2 on your own. Again, you're going to use the formula just like we did here.
you say? Yeah, it's that.
Yeah.
Wait, what do we do if it's hot, negative minus
So you have to figure out what the common ratio is, right? So what are you multiplying by each time you get between terms? Hang on.
Yes. You're right.
It's like, we're doing
Yeah.
this right so far.
Okay, so what are you trying to do here?
I'm trying to get,
You're trying to solve for n?
yeah.
So, okay, so you're told what is the sum of the finite geometric series that's listed here, right? Do you know how many terms you have? So do you have to do this? There you go.
About two. What's my ratio? What am I holding?
Two, six.
He was playing scared
yesterday. Like, he didn't want to get into any physical.
What's your first man? Always plays like that.
Does he? It really showed last night.
This way, I have it.
He was playing like scared.
Now, in this case, we know we're not gonna take serious. We know N.
N is 480, right?
So what did that n value represent?
Last term. No,
Your n value.
Smart.
number of terms. So you just count the number of terms.
Mm-hmm.
Yeah, I do that.
I'm really like, mine's not that hard to match. Yeah.
Ladies, I need you working on that example, please.
Okay, now once you have that, you plug it in and type it in your calculator. So you have everything, you got your R, you got your R, A1.
Do we need a little more time to finish example 2?
How do you get out of test
Yeah.
mode
How do
on
you
this
say
calculator?
it? What's the number of it?
Trust test, how do you get out of that?
Would you get trapped?
It says my thing's like locked.
Yeah.
It's a one.
No, it is.
Like I tried to do something and it wouldn't let me do it.
So, we need to know our R. R is the ratio. How much is that? What are you multiplying that by?
Two.
Is it positive or negative? Okay, so R is equal to negative.
It won't let me do something,
So,
but it won't let me, like I
Now,
tried to
in
type
this
in
case,
something.
we know
Right here,
how
it
many
wouldn't let me.
numbers there
Oh, I
are.
think I tried typing this.
Because
It
there's no
wouldn't let me.
that,
Right.
so you can count them
Yeah, I
up.
don't
We
know.
just need zero. Okay, so N equals 6.
Yeah, you know.
Wait, Mr.
So, write this down. Nope, this is fine. We're on this one? Alright, you're on this one. Okay.
So what's S?
That's what you're trying to find. So start plugging these in. Plug these in.
So I have to get really good.
Wait, where did you get your?
Okay, there's no dot. So we just, it's a finite. Right, and we know how many terms there are. There's 1, 2, 3, 4, 5.
So then this would be. What's, one?
So, okay, so
Tell me that like it wasn't even in the
So here you-
set.
I don't know what
So-
you're gonna say.
What's your?
That's still
primary?
SN, that's what we're looking
Your
for.
second term.
It's
That's
not
the-
6?
What do you have to plug in?
That's the sum. That's after we plug everything in. Okay, so we got negative 15 times 1 minus, what's my ratio? And, well, keep it negative 2 for now.
And then negative 15 times negative 2.
Right. So that, and then
Minus negative 2.
okay, now type it in your calculator exactly the way it looks.
All right, are we finishing up with example 2?
I like to escape, and then that works for me, so it should be okay.
Besides John.
All right, so we're gonna look at this second example now. So we want to find the sum of this finite series. Now, this one is small enough again that you probably could just add them. However, we want to be able to use the formula. So, again, we need that A1 value, we need that R value, and we need our N value. Anytime you're going to do a geometric series, these are the 3 values you're going to need. So what's our A1 value? Negative 15, that's our first term. Then we need to find our R value. Now some of you guys were having an issue finding your R value because we're going negative, positive, negative, positive. So if you're not sure what you're multiplying by, remember how you actually find that common ratio. Remember that you take your second term and you divide by your first term. So you're taking, in this case, you're taking 30 divided by negative 15. When you divide that out, you should get negative 2. Remember that that's how you find that common ratio. You take your second term divided by your first term. Because they're not always going to be nice whole numbers like this. You might have fractions. You might be multiplying by 1/2. You might be multiplying by 1/4. So you need to be able to find that common ratio. So in this case, it's negative 2. And then what's our N value? Our N value is 6. This time we don't have to use the explicit formula because we're given all of our terms. We know all of our terms. We have 1, 2, 3, 4, 5, 6 terms. So we already know our N value. So now we can plug this in to our geometric series formula. So we have negative 15 times 1 minus our R value. Now, this is very important. When you have that negative number, make sure you put that negative number in parentheses. Because you're taking that negative number to some power. If you don't put that in parentheses, you're not actually taking negative 2 to that power. You're taking 2, and then they're going to make it negative. So make sure you're using parentheses. And this is raised to your N value, which was 6. And then we have 1 minus, again, our negative 2. Ladies. So now again, you should be able to plug this into the Inspire just like it is here. But again, make sure you're using those parentheses around that negative 2. And what are we getting? We get 315. And if you wanted to check to make sure that was right using the formula, go ahead and add those 6 terms together. Make sure you get that 315. So 315 is
If you
I
did-
just added it all up and then.
Yes, Josh.
Yeah.
I said for this one, it's small enough that you could have just because all your terms are listed here. So you could have just added this. But I want to make sure that you know how to use this formula.
If you didn't use the parentheses around that -2 before you took it to the 6th power, that was gonna mess some things up.
Yeah.
So,
Yeah, so make sure you're using these parentheses.
I got 180 when I.
You got what?
Like when I times the -15, I got 180.
I'll come talk to you.
I typed in calculator and forgot the wrong answer.
Alright, so
I got it. That's negative.